a relation where each x value corresponds to only one y value. So that part right there, that is basically saying that x's cannot repeat. So if it's a function, then our x values do not repeat, right? So it says another way to visualize this would be that if you are looking at a graph, it would need to pass the vertical line test. If it doesn't pass the vertical line test, that means that there are some repeating x values, right? Because they're stacked above one another. So that being said, they give us some functions in a variety of ways here. For A and B, they write them as coordinate points. For C and D, they drew a picture. They just want us to answer yes or no if we think that they are a function. So what do you guys think about A? No, why not? Right, those x's repeated right there. So that'd be no. What about B? Yes, why? Right, none of the x's repeat. Good. Okay, what about C? Yeah, anywhere I draw a vertical line, or if I did my pencil vertical line test, I'm not going to have any x's that repeat, right? So this one's yes. What about D? No. It definitely does not pass that vertical line test, right? Okay, so it's pretty simple if they give you coordinate points or if they give you the picture to determine if it's a function or not. The only other way they could ask it is maybe they give you an equation and they ask you to determine if it's a function. So you don't have a picture, you don't have coordinate points. But it says if they give you something like A and B here, it says to determine whether y is a function of x, all you need to do is solve the equation for y. So you're going to try and get y by itself. You want the equation to be y equals whatever all the other stuff is. Okay? And then it says in that process, you will find out if it's a function or not. Because it says if that can't be done, so if you cannot solve for y, it's not a function. Also, if you get a solution that is not unique, it is not a function. When I say not unique, that means that there's more than one answer. Okay? Okay, so if it can't be done or if it's not unique, then the answer is no. Otherwise, the answer is yes. So let's take a look at these two parts, A and B. So on part A, my goal is to try and get y by itself. What would I need to do first to try and get y by itself?
Add the 1 to the other side.
Okay, either way, we're just trying to get things on separate sides. Okay, so if I did add the 1, then I would still have square root of x plus 2y equals 1, right? So what else would I still need to move? The square root of x. Yeah, how would I move the square root of x? Subtract it. Okay, so I would have 2y equals negative square root of x plus 1, right? So now, whichever way you went, you now have the other terms on one side and the term with y on the other side. Okay? And then what would I need to do? So those divide out, and I'm left with y equals negative square root of x plus 1 over 2. Now, not great to look at, right? I probably wouldn't want to graph that myself, but did I solve for y? Yeah, and did we just get that one equation? So is this a function? So that's all you have to do. Make sure you can solve for y, and make sure you get one answer. Okay? For part B, if I want to solve this equation, what should I do? Okay, add the 5. So I'd have x minus 3y squared equals 5. Then what should we do? Subtract the x. Okay, so 3y squared equals negative x plus 5. Then what? So now I have y squared equals negative x plus 5 all over negative 3. Now what? take the square root. Okay. All right, and we talked about this a little bit in the last unit because sometimes when we were solving, we had to take a square root. Anytime I take a square root, what do I have to consider? Plus or minus, right? Because it could have been a negative, could have been a positive. We don't know what x is, right? So we can't say for sure. So when I came up with my answer here, I got y equals positive square root of negative x plus 5 over negative 3. And I also got negative square root of negative x plus 5 over negative 3. So is this one a function? No, why not? Two answers, right? Not a unique solution. Good. Okay. So now, no matter what way they give it to you, you can determine if it's a function or not. If they give you coordinate points, check for repetitive x's. They give you a picture, vertical line test. They give you an equation, solve for y. Okay? All right. In this next section, it says evaluate the function at the specified value of the independent variable and simplify. So that was a really fancy way of saying that they want you to evaluate the function for these x values and simplify. Remember, independent is your x values. So find x, plug it in, and simplify. So on part A, they tell you the function is f of x is equal to 2x plus 1, square root of that quantity, minus 3. And they say find f of 4. So normally the letter x is in there, right? But they replaced x with 4. So what do we need to do? Right. So I would have the square root of 2 times 4 plus 1. And then a minus 3 after that, right? Okay? And now I just need to simplify it. So if I'm going to take the square root of that, I probably should simplify what's underneath it first, right? So do I multiply first or do I add first? Multiply. So 2 times 4 is 8, and 8 plus 1? 9, okay? So I have square root of 9 minus 3. Okay, well, what is the square root of 9? 3. So 3 minus 3 would be 0. Okay, and we did take a square root, but I don't have to say plus or minus 3 because we know what we plugged in for x, right? It was a positive 4. So I don't have to do the minus because I do, in fact, know that I plugged in a positive value there. Okay? Okay? For part B, this one says g of t equals the absolute value of t plus 1 over t minus 3. They want us to find g of negative 5. So what should I do? Plug in what? Negative 5. Okay, so I'm going to have the absolute value of negative 5 plus 1 over negative 5 minus 3, right? All right, so in the numerator, we've got negative 5 plus 1, which is negative 4. But it is inside those absolute value bars. So what is an absolute value going to make that negative 4? Positive 4. Okay? Now let's simplify the denominator. So in the denominator, I have negative 5 minus 3, which would be negative 8. Now this part is not inside of an absolute value, so it truly just is negative 8. So we end up with 4 over negative 8. It did say to make sure we simplify. Can I simplify that answer any? Negative 1/2. Okay. Flip it over onto the back. And we've got a piecewise function here. We've got h of x is equal to x squared plus 1. And they say that this is true only when x is less than 0. So this part is only true when x is less than 0. And then they said 3x is true when x is greater than or equal to 0. So 3x is only true for x being greater than or equal to 0. And they say find h of negative 4. Okay? So this is supposed to be the letter x, right? Okay, so would that mean I'm looking at the top rule or the bottom rule? The top rule, okay. So that would be -4 squared plus 1, right? And what is that going to simplify to? 17, right? Because this would be 16 plus 1, which would be 17, okay? Then they ask for h of 2. Which rule would that be? Bottom, okay? So that would be 3 times 2, which is 6. Okay? Then we have part D. Part D says p of x is equal to x squared minus 2x plus 1. And they say to find two things. They say find p of 3x. So what does that mean to do? Plug in 3x anywhere there is x. Okay, so I'm going to take this function, and anywhere I see an x, I'm going to replace it with 3x. So I'll have 3x squared minus 2 times 3x plus 1, right? This question is different than what ended up on the notes. Okay, so order of operations tells me I should simplify what first? Okay, so inside the parentheses. Is there anything to do with the 3x inside of the parenthesis? Anything to do with the 3x inside of this parenthesis? Okay, so after parentheses, what comes next? Exponents. Okay, so I do have one of those. What does it mean to square something? Okay, so this literally means 3x times 3x, right? Which is, what is it? 9x squared. Okay. All right, so I've taken care of the exponent. What do I do after exponents? Multiply. So what is -2 times 3x? -6x. And we got plus 1. All right, the only thing left to do at this point would be to simplify or combine any like terms if we had them, but we don't have any like terms, right? So it's just 9x squared minus 6x plus 1. Now, if they asked us to solve, that's a different story, but they just said simplify. Okay? So we've got p of t plus 3. What does that mean I'm supposed to do?
Add a t, replace p as t plus 3.
Not replace x. Perfect. So replace x with t plus 3. So I'll have t plus 3 squared minus 2 times t plus 3 plus 1. All right. So again, order of operations, where am I going to start? Yeah, the t plus 3 squared, yeah, the exponent. And again, what does it mean to square something? Okay, so this means t plus 3 times t plus 3. That is not t squared plus 9, right? Remember, we're multiplying everything else out too. So t times t, that part will give me the t squared, right? What about t times 3? 3t. All right, and then I've got 3 times t, which would also be 3t. And 3 times 3, which is 9. Okay, can I simplify that any?
Yes.
What can we do?
T squared plus 6t plus 9.
Good. So those two terms in the middle were like terms. Good. All right, so we have taken care of the exponent. Now I'm just going to bring everything else down. So I'm going to have my -2 times t plus 3 plus 1. All right, so we did the exponent. What's next?
Combine like terms.
Well, before we combine like terms, so -2 times t would give us negative 2t. And negative 2 times 3 is negative 6. All right, then I'm just going to bring everything else down. All right, and then what do I do? Combine like terms. Okay, so we start with our largest exponent, which would be t squared. Does it have any like terms? No. Okay, so it's just t squared, so that's gone. All right, next would be all the terms with t in it. Do we have any like terms there?
Yes.
Yeah, we've got 6t and negative 2t, which would be 4t, so plus 4t. So now those are gone. All right, and then all of my constants. I've got 9, negative 6, and 1, which would give us, good. And there we go. All right, and then there is one thing that is going to be on your assignment that we have talked about before, but I just wanted to refresh your memory. So I'm going to write it here at the bottom of the notes page if you want to write it down as well. So we talked about domain and range earlier in the year. And in that very first unit, I reminded you guys that there are a couple of restrictions. So sometimes you don't even need to see the picture to know what the domain or the range is going to be. One of those examples, so let's say we're talking about the domain of, we'll say x squared plus 4 over x minus 3. Okay, well, we know that you're not allowed to have what number in the bottom of a fraction?
0.
0. Okay, so what would I not want to plug in for x because it would give me 0? 3, right. So I don't want x to equal 3, right? If x equals 3, this function is undefined, doesn't exist, right? But I want it to exist everywhere else, right? So for my x values, remember we said you could write your domain and range a couple of ways. You could do interval or set notation, or inequality notation is basically what set notation is. Okay, so if I were to do interval notation is when you use the parentheses and the brackets. So that would look something like, okay, this goes from negative infinity all the way to 3, right? And then it stops because it doesn't exist at 3. And then it would go from 3 to positive infinity. I use the parentheses instead of brackets because the 3 is not included, right? We're saying we don't want it to exist at 3. If you were to write it as set notation, well, actually, let me do it as inequality notation first. So inequality notation was the other way that some of us were writing it whenever we did this earlier. And we would say that if it doesn't equal negative 3, then it goes from negative infinity is less than x is less than 3. And then 3 is less than x is less than infinity, right? Okay, for set notation, it looks pretty much the same, only it's inside of this bracket. So you would say x is all real numbers, or x is all of these things, such that, and you would just copy this part down. So you'd bring down your negative infinity is less than x is less than 3. 3 is less than x is less than infinity. And you put it inside of those curly brackets to show that it's a set. So inequality and set notation are pretty much the same. The set notation is just the fancier way of writing it. Okay. All right, the other rule, besides not being able to have 0 in the bottom of a fraction, was a square root rule. So let's say you had x minus 7. Okay, we cannot take the square root of a negative number, right? If you put a square root of a negative number in your calculator, it says like error or something like that. Okay, so I would need to make sure that whatever we're plugging in for x is going to keep it positive under there, right? What's the smallest number that I can plug in for x and still get a positive under there? 8, okay? If I plug in 7, I would get 0, which is still not technically negative, right? But what if I did 6.9? Is that going to work? No. So it literally has to be 7 or anything bigger if I want it to be positive, right? Okay, so I would say for inequality notation that I want it to be 7 or bigger, right? So it's greater than or equal to 7. Or if I'm doing interval notation. Interval notation would be that we're saying that that x is from 7 off to infinity. And 7 has the equal sign with it or the bracket because it's included. If they wanted it as set, we would say x is the set of all real numbers such that x is greater than or equal to 7. So again, these two kind of match each other, just the fancy way of writing it. Okay? So just wanted to remind you of those two rules. If you forget those two rules and you have your graphing calculator, you can always just graph it and look at the picture as well. So you'll have your graphing calculator with you. Just wanted to remind you of those two rules that we know about.